Hello, welcome to notes number 4 of our anthropology unit, Forensic Osteology. Today we're going to learn all about how forensic scientists can use bones as evidence. The overview, the main point that I want you to take away from these notes are that from a human skeleton, forensic anthropologists can determine things like age, gender, and some other info about their lifestyle. So the goal by the end of these notes is for you to understand how they do all of these things. So we're going to start with age first. Okay, the first thing to know is that before bone is made of bone, it's actually made of cartilage. So when you are developing in your mother's womb, all of your bones start as cartilage first. And then, as you develop, those bones are calcified and turn from cartilage into bone. So at birth you have approximately 300 quote-unquote bones, but as you grow, those bones are going to calcify and they're going to combine and fuse together. So as an adult, you're going to have 206. Now, bone cannot grow. Once the cartilage has turned into bone and is calcified, that bone won't grow anymore. So how do you grow then if your bones don't grow? There is something at the ends of your bones called growth plates. You can see them here. This is not 3 separate bones. This is one bone through a progression over time. So there is cartilage at the joints, and that's just to help your joints move without grinding bones against each other. But what we care about is this cartilage that's near the end of your bones. So if you think of let's say your leg bone, your bone grows from the ends, but not from the very, very ends, because the very, very ends are actually involved in joints. So it really wouldn't work for your body to grow from the joints. It would be too painful and they'd all be getting out of whack all the time. So they actually grow from a little strip of cartilage near the end of by the joint. And this cartilage grows on one end, pushing the bone further and further and further out, elongating it. And on the other end, over on this side, the cartilage becomes calcified and is replaced by bone. So over time, this whole blue area here that used to be cartilage is now bone in this later picture, because the cartilage, the growth plate, has actually pushed forward, and over more time it will go as well. But what happens if you go long enough, as you grow and grow and grow, eventually this calcification will outpace the new growth, and this growth plate will close, and you will no longer have any more growth in that bone. So the way that forensic scientists use this, here's an actual x-ray of a teenager's bone, and you can see, or a child's bone, and you can see where the cartilage is on the bones. So from a forensic scientist point of view, if the cartilage can be seen at the ends of bones, we can see those growth plates, then we know there's going to be further growth. But if we find a skeleton where there's no growth plate spots, we know that the growing is done. And we know from research that on average, females grow until they're about 18 years old, and males grow until they're about 20 to 21 years old. So as a forensic scientist, if I find a skeleton that still has growth plates in it, and I determine it to be a female, then I can estimate that female's age to be less than 18. And if it's a male's, I can estimate it to be less than 20. So that's the first way that forensic scientists can use the bones to determine the age. Another way that we can determine age by the skeleton is looking at bone density. Remember from all your science classes, density equals mass over volume. So it's literally how many molecules there are in a given area. With bones, you have this balance. All your life, minerals are being deposited and removed from your bone. But how this works is, as you're young, from birth till 18, while your bones are still growing, your deposits are definitely way more than your mineral loss. So if you find a bone in a child or an adolescent or teenager, the bone is going to have a really, really high bone density. Between when your bones stop growing and about 35, your deposits and mineral loss is approximately even. So that high density is still there. So the only way to tell a bone from, let's say, a 17-year-old versus a 34-year-old is probably going to be that the 17-year-old is still going to have growth plates because their bone density is going to be the same. But once you get past 35, your bone loss exceeds your deposits. So as you get older and older and older, your bone density goes down. And this becomes a problem when you become really old. I'm sure you've heard of people like, oh, their grandmother broke their hip. Well, it's not because they had some crazy violent fall. It's most likely they had a pretty normal kind of incident that you might have on a day-to-day basis and not think of anything of it, but because their bones are so low in their density that they break. So that's another key way that we can estimate age of a skeleton based on how dense their bones are. There are other ways to look at age in bones. The next one is looking at the rib bones, and specifically the sternal ends of your rib cage. So your ribs are attached to your vertebrae in the back, and in the front they attach to your sternum, which is your breastbone, but they're not attached bone to bone. They actually have a piece of cartilage right here in your rib cage that attaches the rib to the sternum. And so it's these ends of your ribs, which we call sternal ends, and the shape change over time. So when you are really young, from birth all the way till kind of young adults-ish, 18, 19, 20-ish, those are very, very round, these ends right here that attach to the cartilage of your sternum. As you get older, your ribs start to become more and more kidney bean shape. They kind of become more flattened and jagged. So if you have ever eaten ribs, if you are not a vegetarian or vegan, if you eat ribs, you probably know what I'm talking about. The pretty quintessential shape for a rib is kind of that more elongated, almost kidney bean shape. That shows you that that animal was older versus if you buy, let's say, baby back ribs, that's from a very young animal, and those ribs should be very, very circular. So looking at the shape of the sternal ends of the ribs is another clue to tell us how old the person was that we found the skeleton for. Okay, we're going to shift away from age, and we're going to look at male versus female. And your pelvis is the key thing that we look at, your hips. Now, you can look at this pelvis. You can see I've color-coded it and put letters on it, so you can see it's actually made of multiple different bones at birth that then fuse together as you get older. So we're going to go through the names here. The yellow section, these big parts, basically your hip bones, are called the ilium. The pinkish part in the front is called your pubis. And the bottom part, the kind of the wing area where your leg bone attaches to your pelvis, is called the ischium. The back of your pelvis is called the sacrum, and your tailbone, which on my thing is light blue, is called the coccyx. So your pelvis is actually made of 5 different bone sections at birth, and as you get older, they fuse together. Actually, very, very young, very early. It's one of the reasons babies can't walk too early, is because their pelvis isn't all fused together, and so they can't support the weight of the baby. So it's really early, within the first 5 or 6 months, that the pelvic girdle actually starts to fuse together. Now, the reason they're separate at birth and fuse together later is because the hips are one of the widest parts of the baby, and in order to go through the birth canal during birth, they need to be able to be squished and mushed and manipulated to get through there. So that's why it's in multiple pieces. Looking at the pelvic girdle and comparing females to males, there's actually a bunch of differences. So we're going to look at this from the female perspective. Females have a wider pelvis than the males. The middle section of the pelvis, which we call the pubic arch, is wider as well. And the bones are actually a different consistency. Bones in females, your pelvises are lighter and smoother than males. And the reason that the actual composition of the female pelvis is different is because if that woman decides to have their own children someday, there's a hormone that is released during labor, during birth, that makes the pelvis, and only the pelvis, more flexible, so that as the woman pushes the baby through the pelvis can bend and stretch without breaking. Also, in order to allow the baby's head to go through the middle of the pelvis, the sacrum is shorter than the male's, so the back part of that pelvis doesn't hang down as long, and the coccyx, the tailbone, is way more movable. So here's a picture on the left of a male's pelvis, and here's a picture of a female's pelvis. You can see it's much wider, and the hole in the middle, perfectly shaped for a baby to go through, is much larger. Again, the reason there's these differences between a male and a female are for childbirth, and it's the #1 way that forensic scientists can tell if a skeleton belongs to a male or a female. Here's an actual, rather than a picture, an actual female pelvis. And fun fact, I didn't know this until I was having my own children, but when the baby is being birthed, they actually start sideways so that their head can fit through the hole in the pelvis. And then once they get their head through, they actually rotate and face the mother's rear so that their shoulders can then fit through that hole in the pelvis. So they do this kind of acrobatic thing while they're birthing. Next, we're going to talk about skulls, and skulls are multi-useful. They can both tell us helpful information about age, as well as information about male versus female. So first we're going to look at skulls of very, very, very young adolescents, babies, in order to understand how the skull develops, because that's going to help us understand how we can use it to determine age. So on the left here we have a picture of a skull of an adult, and you can see it's one piece. Actually, it's two pieces, my apologies. There's the main cranium part, and then there's the mandible, your jaw. In a baby, however, we have multiple pieces. An infant skull is not fused together. Again, just like the pelvis, the skull is in multiple parts. The spaces in between all of those pieces of bone are called fontanelles. If you've ever held a baby, like a very, very young baby, you know they have soft spots on their head that you don't want to push on because there's literally no skull there. Humans are a weird species in that we're born early before our brain is done developing, because if our brain developed all the way in the womb, then our heads would be too big to actually have a woman birth the baby. So the skull is not finished developing, the brain's not done developing, and the brain is made, the cranium, the skull is made of a whole bunch of different pieces that are able to be squished as the baby is being pushed out through the birth canal. And that's why most babies who are born vaginally come out kind of cone-headed, because all of these different bones are being pushed and smushed as the baby's pushed out. As the baby grows and develops, the parts of the cranium all fuse together, the fontanelles are filled in, and you get what we call cranial sutures. So it looks like the brain has been stitched together, because in reality, those pieces were stitched together. And this is going to be key in determining how old someone is from their skull. So if you've ever got a really bad cut, you probably have a scar on your skin. But what you've probably noticed is that over time, your skin and your scar has healed and your scar has gone away. And the same thing happens with your bones. There's something we call bone remodeling. Essentially, your quote-unquote scar lines where your bones weren't together and now are will disappear over time. So if you look at the picture on the left, you can see the cranial sutures from where those different parts of the cranium fuse together are very prominent in this one. And on the skull on the right, they're almost not there at all. So I can tell from this picture that this skull on the left is significantly younger than this bone on the right. And forensic anthropologists have seen so many skulls that they can actually give you an age estimate based on the cranial suture lines that are there when they see a recovered skull. The other thing we can do with skulls, other than determining their age based on the cranial sutures, is looking at the differences between male and female. So with the pelvis, we looked at it from the female point of view. For skulls, we're going to look at it from the male point of view. So men, compared to female skulls, males have a thicker skull. So literally, men are thick-skulled. The skull tends to be heavier and larger and have a larger cranial ridge. If you've ever tried to walk around with books on top of your head, this is generally easier for women than men because men tend to have an actual ridge that runs along the top of their skull, and it makes it difficult to carry books or water or things like that. Their jaw is also larger, and they generally have a more pronounced temporal ridge line, which I'll explain what that is. All these basically say that male skulls more resemble cavemen than females. The pictures here on the left is a male skull and the right is a female skull. Let me explain this more pronounced temporal ridge. If you look at a skull, where the mandible attaches to the skull, there's a really big muscle that attaches your jaw. And if you put your hands up by your ears and you move your jaw, you can actually feel it. Put your fingers above your ears and you move your jaw, you can actually feel that muscle moving as you do that. And because males tend to have larger jaws than females, that muscle is bigger and it leaves a bigger impression in the skull than it does on a female. So you can actually look at just the temporal line, is what they call it, from that muscle. Now, there are more differences. If you look at the eye sockets, the orbitals, males tend to have more square orbitals and females' orbitals tend to be more round. So on the left is a male again, and on the right is a female. You can see the orbital on this skull is very round compared to this one. It's a little more squared off. Again, here's the females, a little more round compared to the males. And finally, females tend to have more vertical forehead. You can see the forehead goes up a little more before it goes back, whereas men's tend to recede very quickly. The final thing that we're going to talk about in terms of how anthropologists can use skeletons to help us with investigations other than age and sex. One of the things we can tell is if a bone has been used a lot. If a part of the body has been used a lot, then the bones tend to be larger than the bones that are used not as much. It makes sense. If you use a part of your body a lot, you're going to build up the muscle there, and your body needs the infrastructure in order to support that bigger muscle. So if you've used your right arm way more than your left arm, the muscles in your right arm are more developed, and your body has to put more minerals into the bones on your right arm in order to support those larger muscles. And so you can tell if somebody is right or left-handed because they've used that muscle more, therefore the bone has been bigger. You can even tell if someone has a really active lifestyle, like are they a runner, or do they work out a lot, or do they participate in a sport or something like that, versus somebody who spends all of their time sitting in a chair and being kind of a couch potato, because the bones will actually be a little bit thicker. Another couple things that you can tell from bones are injuries. If you've got an injury where you broke a bone, just like the cranial sutures, you will see sutures within the bone where they fused back together after being broken. And there are some diseases that you will actually show up in your bones, like arthritis or osteoporosis, where there's actually a degradation of the bone from the disease. Here's a picture of a bone that was broken and it didn't get set correctly, so you can really see where it had been broken. Those suture marks are very prominent. Now that person, wherever that part of their body, that probably hurt the rest of their life because it didn't set correctly. But those are some other things. So again, the key takeaways from these notes today are that we can use bones as evidence to help us determine if the victim was male or female, how old they were approximately, and then some other things like injuries, diseases, and maybe even their lifestyle, sedentary versus active. Please make sure you answer the questions that are attached in the Google Classroom for these notes, and I'll talk to you next time.